So let's talk about what exponential functions are. So this is the beginning of this unit. We're going to start by talking about exponentials. So first of all, what is an exponential function? An exponential function is any function with a variable in its exponent. Hence it's called exponential because the variable is in its exponent. The normal ways you see this are either y equals a times b raised to the x, or y equals pe to the rt. And these two equations are both exponentials. They're just written a little bit differently, and they're slightly different types, but they're both exponential because both of them have their variable in the exponent. In this case it's x, in this case it's t. All these other letters really just represent numbers we don't know yet. Those are constants, they're not variables. We're not going to be plugging different things into them. We're going to be finding what they equal and just sticking with that number. Okay, so let's talk about the pieces of this equation. First of all, for both of these, a in the first one and p in the second one, it represents your initial amount. If you watch the very first video in this set, we saw that when we plugged in, or actually maybe it was the second video, I think it was the second video, when you plug in 0 for x in this first one right here, all that's left over is a, because b to the 0 would just be 1, and that would just give you a. And same thing with p. If you were to plug in 0 for t over here, then you would just get e to the 0, which is 1, and that would just disappear and you'd just be left with p. So that's your initial amount. It's what you start with. B and R are your rate of change. Okay, if you watched the previous video when we talked about the penny experiment, we knew that the rate of change for the pennies should be about 1/2 because we were removing all of the tails, and we should get tails about 1/2 of the time. So we put 1/2 right there in B. This second equation can be used for lots of different things, but one thing it's used for often is for interest problems. And that's why they have R, because that can be your interest rate. So for example, if the interest rate is 5%, you would put 0.05 in for R. You put the decimal form. Okay, another cool thing about this is you can tell based on B and R whether this is exponential growth or exponential decay. So for example, with B, if b is greater than 1, then it is an exponential growth problem. The same thing will be true if r is greater than 0. So again, the equations are slightly different in the way they're set up. So for b, it just has to be bigger than 1. For r, it has to be bigger than 0. So it just has to be positive for r. So you can probably figure out what the alternative would be. If b is less than 1 and r is less than 0, then it's exponential decay. Just to give you an idea of what the difference would be, exponential growth is going to look something like this, whereas exponential decay is going to look something like this.